Hi folks, Miguel here again with another video for you. I wanted to revisit one of the latest videos I made where I tried to illustrate and tried to show you that when you capture an image, there's an inherent amount of distortion in it, and that could be radial distortion where things kind of take this bubble shape, and then also perspective distortion. And I wanted to kind of show you the relationship between them. What I want to do is I want to try to go about this in a different way. And what I've got here in front of you right now is my camera looking straight down at this particular playing card. And if this card, let's assume this card is manufactured very cut very well is what I'm trying to get out here. If you take a look at this, you'll see that it pretty much looks like a rectangle in this portrait mode you've got right here. But you know, I can try to make my way around this playing card and show you a measurement across the top, and then one across the middle, and then one across the bottom, and try to isolate those very minor tweaks in those measurements to try to illustrate that there is distortion happening here. But you know what? I really think that there's a better way to show you that distortion than to try to squeeze it out of an image like this. If we go live, and I take that camera, which I measured to be level, I'm gonna give it approximately, let's say about 30 degrees of tilt relative to the surface of my desk here. And then I'm gonna give you the same image or the same part. And then of course, because it's further away at a different angle, I'm gonna have to compensate just a little bit due to the focus, right? And there we go, I think that's pretty good right there. Let's go with that. So what I want to show you now is that it should be pretty easy for us to say, hey, this is a playing card. It's supposed to be perfectly cut in a rectangular shape. However, we can clearly see that it doesn't look like a perfect rectangle, right? If you look across the top, you'll see that because that portion is closer to the camera, it appears bigger, and then the bottom appears smaller because it is further away from the camera. And then if we want to measure this out and actually quantify this, we can do that very easily, and the result is going to be dramatic. Let's go ahead and put a measurement tool across the top here. Let's grab this feature and, oops, I think I missed that. Let's try that again. This feature and this feature, beautiful. All right, and what I want to try to accomplish here is I want to get a straight across distance as opposed to a little bit of a diagonal there, or you know what, I might be able to just, there we go, I can just tweak this, and let's get ourselves a straight across distance, about 691 pixels. All right, let's do the same thing, but let's do it across the bottom. So I'm going to pick features down at the bottom, right here, and right over here. And what I'm going to do now is I'm going to measure across the bottom, and I do not want the diagonal distance. So let's go ahead and tweak that just a little bit. Yeah, that should be pretty good there. And you can see here, there is a dramatic difference between the measurement across the top and the measurement across the bottom. So not only can we visualize this, but we can quantify it and say, look, even though this playing card is cut straight across and it's a rectangle, we can clearly see that the image is not showing us a perfectly cut card. And if we tried to make any measurements without a calibration here, we'd be in a lot of trouble. We couldn't really perform them. Even if we tried to do a scale calibration, the scale wouldn't work across the entire field of view. So here's what we're going to do. We're going to go ahead and we're going to perform something very similar to this, except we're going to go back to setup image, and I want to go ahead and set up a calibration. I'm going to go to calibration. We're going to do a grid calibration, and I'm going to click on the calibrate button here, and I'm going to tell it that I'm doing a checkerboard with a fiducial with 5mm spacing. That's the kind of grid I got here with me, and I'm just going to go ahead and go on to the next step. That's all I really need to tweak there. Then what I'm going to do is I'm going to go live, and I'm going to introduce my grid. And what I'm going to do is I'm going to put that grid right on top of where that measurement, we were attempting to make that measurement, something like this. And if you look closely, you should be able to see the distortion being the distortion that's visible here essentially, right? So I'm going to put that right there, and I'm going to capture that image because that is the image I'm going to perform a calibration on. And because I told the tool it's 5mm spacing, it's going to extract a whole bunch of data points here. In fact, it's going to extract 296 data points and use those to perform this calibration. Let's go ahead and click calibrate, and it takes me to here, a result that is 0.939 at marginal. So right here, when I get to this part of the class, if I'm using a piece of paper like I am here, what I want to explain to folks is that they shouldn't take this performance personal. A lot of times folks look at this and go, oh no, what did I do? Should I have changed something in a previous step? The answer is no. The only thing you can really do to improve this is to get yourself a grid that is manufactured to be exact and precise and 100% accurate. If you can do that, you're going to see this evaluation of your grid just hug right up against the 0 here and get the excellent score that you're normally looking for. On a piece of paper, it's kind of tough to do that because the piece of paper, by definition, it's a piece of paper, therefore it's very flexible and it can bend and get a wavy pattern, right? But we can use this for the example that we're trying to accomplish here, because we're simply trying to show you that in order for us to make a measurement that is logical and that is going to give us the highest level of accuracy, we're going to have to take this approach. So let's go ahead and use that information. Let's click OK. And let's go ahead and get that grid out of there. Let's go back to live. Let's get the grid out of there. And let's go back to our playing card. Beautiful. And if we go back to our playing card, what you'll find is that now suddenly all of these guys are saying, hey, I'm getting the wrong measurement. I'm getting well, not the wrong measurement, but they're all out of tolerance. And you can see that this right here says, hey, 63.5 and 64.19. Wait a second. Those are 50 pixels off before. These are now very close to each other because of the calibration that we performed. That's how easy it is. If you want to take those measurements, calibrate them, and undo any kind of perspective distortion, you can use this technique to give you those measurements. Now, what we would do here is, of course, go into those distance measurements. They were in pixels before, and they were now far out of tolerance. Let's go ahead and set the range limits up one more time. Let's hit auto for that guy, and let's hit auto for this guy as well. We're kind of making the assumption that this card is within tolerance, but basically we're saying we're looking for somewhere around 63.5 and 64 millimeters here. These are off by about 0.6 millimeters now, right? A lot closer because we have removed that perspective distortion now. Now you might say, hey, wait a second, didn't you say this was a perfectly cut card? Shouldn't it be exactly the same if we had a perfect calibration, right? Didn't you say we could remove perspective error and remove this radial distortion you discussed? Why don't they measure exactly the same if you're using an exact perfect card? The answer is they should measure exactly the same. Two things that I would be able to point to that would make us not measure exactly the same right here, and this is for you who's listening to this and for you to pass on to your audience, your customer, whoever you're explaining this to. There are two factors right now that I believe would contribute to us not having the exact same measurement, this 63.5 and this 64.1. And that is number one, is the card truly perfectly cut? Did you confirm that? Did you verify? Is that card truly a golden template card that you can in fact use to determine if it is cut equally on both sides, right? I don't know that. I don't have the tools to measure that card physically here. I'm using the vision tools, right? So that's the first thing I would check. Hey, does the part actually measure the distance that you think it should measure, right? That's the first question you want to ask yourself. And number two, remember back to my grid where I showed you, hey, if you use a piece of paper, you're not going to get into the excellent zone. In fact, you saw that we were square in the middle of the marginal zone, right? We weren't even going into marginal, pushing into good. We were deep in the marginal section. If I wanted these values to be more exact and closer to one another, I would want to make sure that I have those values and those values are pushing up against the good and excellent side. The better I can get a grid in front of the camera, the closer and the more repeatable my results will be. All right. So that's part one. I want to show you one other thing while we're here in EasyBuilder, and then we'll flip over to spreadsheets. The other piece that I wanted to show you was that sometimes people look at this image and they go, boy, wouldn't it be great if I could see the undistorted image? Like you're saying that the calibration is magically taking this distortion out. How can I see that? Like, how can I visualize that? How can I see the before and after, or how can I see visually how much distortion is the tool actually taking out of the image? I got something for you. If you guys head into your inspect part step here, you will find an area called image filter tools, and most of the time people go in here and they're really interested in just kind of tweaking the image to improve contrast, to get rid of noise. But if you look closely, there is a transform filter there. And if you use it, let me add it right now. I'm gonna say, hey, let's go for the whole image, okay? And by the way, the only way this works is if you actually have a grid calibration in place. This actually won't do the thing that I'm gonna show you right now unless you have a valid grid calibration in place. So having said that, I'm gonna choose most of the entire field of view. In fact, why don't we just do the entire field of view? Let's go big in this case. And I'm gonna click OK. And I'm gonna show you something. Keep your eyes on the card while I click OK. And as soon as I do that, you'll see a dramatic change happen right in front of your eyes, because what's gonna happen is we are in fact going to transform that card from the distorted version of the image, where I had my approximately 30-degree point of view onto that card, to the undistorted version of that card based on the grid calibration that you performed originally, right? So I think those two things go very far to show somebody, hey, we can make measurements, we can make calibrated, accurate measurements, and if your measurements don't quite look exactly super tight and exactly right, where do you look? How do you solve? Where do you investigate so you can get those measurements to match 100%? And then number two, hey, why don't you show the customer or your audience what the undistorted image looks like, right? That's a very powerful visual that you can use to your advantage to let people know, not only can we get you the measurements, we'll even show you all of the distortion that we're able to take out of this part. All right, well, I hope that helps illustrate what I wanted to get across to you in a clean manner. The other piece that I wanted to show you is I wanted to show you how you go about doing this in the world of spreadsheets. So stay tuned. I've got another video for you that is actually going to show you how to do that same exact exercise where we're making those measurements, but we're going to do that in the spreadsheet world. Thanks.